welcome back to the DevOpsCon online edition. I hope you all had a nice lunch break. My name is Dominic Mohilo, and I am editor for the German Java magazine and JuxCenter.com. The following session is about the past, present, and future of cloud-native API gateways, and it is held by Daniel Bryant, product architect at DataWire and news manager at InfoQ. Hi, Daniel.
Hello.
Before I go to Daniel, just a little bit of information. You can use the chat in Swapcard to get help by our technical stuff if there are any problems, but you can also use it for just chatting and commenting on the session. You can also ask questions, either via the integrated Q&A tool or via chat. After the session, if there's time, Daniel will answer the questions. And if there's no time left, we will just prepare a Q&A with all the speakers that had to answer delayed questions and give them over our portal to the audience. And with that, I'm pleased to announce Daniel Bryant.
Thank you very much. I'll share my screen so we're all good. And just make this. Oh, 1 second, I'll just drag my Zoom around. Apologies, everyone. Yeah, so thanks for the intro there, and welcome everyone to the past, present, and future of cloud-native API gateways, coming at you from my home office here. I'll introduce myself in a second, but I always like to start my talks with a high-level TLDR, kind of key takeaways. Today, I'm pitching that the edge and API gateways have undergone a series of evolutions, primarily over the last 20 years, driven by architecture and technology. As we're now over the last 5 or so years moving to this cloud native, in quotes, way of working, it's a change in workflow in addition to architecture and technology. We're adopting all things microservices, functions, cloud, Kubernetes, and this is really allowing us to realize the dream that many of us have had about the fast feedback loop for many years, but the tech and the processes and the workflows are now here. The interesting thing is the workflow changes drive changes to the way we deploy and run apps. I've learned this the hard way on a few projects over the last 5 or so years. My pitch today is choose your platform components when you're moving to the cloud very intentionally. Now, we're going to focus on Kubernetes and the API gateway today, but there's a kind of meta message here in that don't just lift and shift what you're using in your colos or your VMs or your on-premises or wherever you're currently deploying. Don't just lift and shift that tech into the cloud world. It doesn't perform as optimally as you'd like. And again, it doesn't really give you the full advantages of the new workflows that are unlocked by this cloud native way of working. This is me at Daniel Bryant UK on most of the interwebs. You can find me on GitHub, on Twitter, on that, LinkedIn. I work as a product architect at DataWire, based out of Boston, although I'm based in the UK. Full disclosure, I do work on the open source ambassador API gateway, hence the t-shirt here. Not going to be pitching that much today, but if you do want to know more, pop along to getambassador.io. We're actually donating the project to the CNCF, so it's going to be fully sort of open source and CNCF-ified very soon, hopefully. I also write for InfoQ, long-time Java developer. Recently, my buddy Abraham Rinprez and I put a book out, Continuous Delivery in Java. That book talks about some of the concepts I'm going to talk about today, but obviously it covers a lot more stuff about continuous delivery that both myself and Abraham have learned the hard way over the years. So we'd love your feedback on that book. But yeah, do find me on Twitter. Love to get your tweets out. DMs are open as well. Today, I'm going to be talking about the edge and API gateways. And I wanted to set this first slide up around the edge and what it is, because the edge means many things to many people. It can mean IoT, kind of real edge devices. It can mean points of presence. It can also mean edge of your data center. And that's what I'm focusing on today. Edge of the data center is traditionally where you've seen things like edge proxies, reverse proxies, ingress, API gateways. That, when I say edge, today that's what I'm referring to. As I hinted at in the TLDR, the thesis really over the past 20, 25 years is that the evolution of the edge, that data center edge, and the technology with it has been driven by changes in application architecture and changes in technology itself. We'll do a bit of a whistle-stop tour now of some of those changes, about 10 minutes or so, which will set the scene for the new challenges we have in this cloud-native world. And then we'll look at some of the problems I've seen when folks are moving to Kubernetes and trying to sort of bring their old mental model of API gateways into Kubernetes. We'll look at some strategies around how you can hopefully improve your decision making, your journey towards API gateways and Kubernetes and so forth. This is the thesis we're kicking off with. So back in 95, in fairness, I'm not that old. I was in high school in 95, but I was really getting into like things like Java and programming and these kind of things, CGI back in the day and Perl, that good stuff. But in the late 90s, when the web was kind of emerging, this was the application architecture du jour. We had, monolithic J2EE servers, we had database at the back end, and at this time, we weren't really sure what the client was going to be at the front end. This is when kind of browsers weren't as solid as they are now. There was discussion at the time, is it going to be something more like applets at the front end? Well, of course, we all know where applets have gone to now, right? And the browser is clearly dominant. But this was the application architecture in the late 90s. Fronting this at the edge was hardware load balancers. Now, the interesting thing here is the target user for this tech was sysadmins, proper ops platform, as we kind of traditionally say, ops folks as opposed to dev folks. The purpose for the hardware load balancer was high availability and scalability. Load balancing across multiple instances. Often we had sticky sessions, so one user constantly went to the same instance. But if one of those instances broke, health checks would pick it up and they'd reroute traffic accordingly. If we move into the 2000s, kind of the web boom, kind of came and went kind of thing. Similar application architectures, if I'm honest, even as we move through to sort of online shops and so forth around the sort of big bust of the web, initial web. Still same applications, a lot of Java, a lot of .NET in this space in my experience here, but we started seeing the rise of software at the edge. HA proxy, believe it or not, 2001. Nginx, again, believe it or not, 2002. These are nearly 20-year-old technologies and they're still going strong today. But these were revolutionary at the time because they were software-based edge controllers. Before it was all, dedicated hardware, hard to change, expensive to run. These kind of, these were game changers when we moved towards software-driven edge components. This was still pre-DevOps, sysadmins were the target users. Still, the focus was high availability and scalability, pretty much, load balancing, health checks, a bit more, we didn't call it observability back in the day, but a bit more focus on monitoring and so forth. But the big benefit was it was easier to deploy and cheaper to run this software at the edge. If we go into 2005, this is where my career really got going. I was doing a lot of work on the Web 2.0. Now, this probably is showing my age, but I was doing a lot of work in e-commerce at the time. Amazon, a bunch of other sites were kicking off. I was working for smaller UK companies, but it was an exciting time to be in tech. The web was becoming a lot more dynamic. Now, again, anyone who's a similar age to me will recognize Ajax as being a huge thing at the time. Up until Ajax became a thing, it was very monolithic request and responses to the back end. I made a request as a user, I got a whole web page back. I made another request, I got a whole page back. Ajax gave us the ability to make these small requests and build the web page, build the DOM effectively, dynamically. And this was a game changer back in the day. But it did change the way we interacted with back-end systems. And if you're in the dev space, you may not have bumped into this, but I definitely did on one gig I was working on, or several gigs actually, something called the application delivery controllers. Now, these were often the realm of the ops folks. And again, if you consider yourself more of a dev, you may not have bumped into this, but this was sort of as a result of this new Web 2.0 model. You're making many more requests to the back end, smaller requests, and you want to offload some of the cross-cutting concerns because you're doing lots of requests now. And the ADC, the application delivery controller, was the resulting technology that did a lot of this stuff. The target user was still sysadmins very much. And again, not everyone, there's sort of a marketing term, ADCs, but it became very much a technology that was used. It was all about high availability, similar to the previous edge components, but it was focused on app acceleration. SSL offload, that was a big issue when CPU cycles were a real scarce resource. And now it's like TLS, and we don't really think too much about it. But back at this time, SSL offload was a big deal, as was caching and compression, gzipping responses, these kind of things. Still lots of load balancing as well. Did a lot of work with F5, Big IP. Nginx were doing a lot of ADC work as well. It's quite kind of funny now, they've come full circle when the F5 has bought Nginx. So they were the kind of leaders in the hardware and the software varieties of these ADCs, and now they've become one organization practically. 2010s, this is the proliferation of APIs. I was doing a lot of work in Google Maps at the time, a lot of work with Stripe, these kind of things. And this is when we see the rise of what we're now calling API gateways. Our company Mashape at the time led to the creation of Kong, very popular gateway you see now. And this is the first time we saw edge technologies being targeted at sysadmins and API developers. The idea was monetizing, creating an ecosystem around these APIs. You could mash them up, deliver more extensive services, and charge money ultimately for these things. At the time, we also saw a lot more push towards layer 7 in the OSI stack. Previously, a lot of the load balancing was layer 4, layer 3, kind of IP addresses, ports, this kind of thing, domain names. Layer 7, when we started moving to API gateways, we could look into the HTTP request. We could look at headers in the HTTP request, or we could look into an AMQP request and look at the metadata within the messaging. And we could make routing decisions based on that. We started doing a lot more at this higher level of the OSI stack. We could be very clever about what devices we're looking at the web pages and these kind of things that were encoded in the metadata. 2015, anyone remembers this time, the famous fail whale? I was doing a lot of work in this time around monoliths, particularly Ruby on Rails, which was where Twitter was built as well. Again, I was working more in UK companies, but we were seeing the same thing. This big monolith we built simply couldn't scale as more and more folks jumped on the web and started using it. This is the famous kind of, when you start seeing people breaking off what we're now calling microservices from their monolith. You often still had, ADC up front, load balancer, but the monolith was often doing a lot of routing to the sort of broken off services. So more and more stuff was getting put into the monolith, and we were coupled with the monolith and our services. If we wanted to tweak, say, the auth or the rate limiting in a service, we often had to crack open the monolith and do some code changes there. And if the monolith was on a slow release train, well, that was quite painful for us as developers. But this was an interesting trend that obviously cascaded more and more to the second generation of API gateways. When we sort of, the true vision, if you like, of microservices, we pulled out a lot of cross-cutting functionality, like auth, like rate limiting, into this API gateway, and the monolith, the mini-lith, just became another service effectively. Now, the target here is still very much the same, sysadmins and API developers. We now say DevOps, right? If you're full stack, DevOps type person, you would be interacting with the API gateway as much as you're interacting with the code potentially. The idea was centralizing cross-cutting app concerns like auth, like rate limiting, all that good stuff. Monitoring and routing became a much more important thing. You wanted to see the results of your decisions, and you wanted to tweak things accordingly as well. This is where we sort of at now with the gateways. Again, Ambassador, the solo folks have got Glue, there's Kong, there's Contour, there's all the classics still around now like Nginx, HA Proxy. It's a very rich area, and I'll be honest and say we as an industry haven't fully defined what API gateway means. So you often hear folks saying API gateway or ingress in the Kubernetes world, and they'll say proxy, and they kind of often mean different things, and I'm guilty of it too. So I'll try and sort of talk through about API gateways a bit more as we go on, but I'm looking at sort of the ingress of Kubernetes, that when you're looking for a richer feature set, these kind of things, auth, rate limiting, monitoring, routing, I'm saying that's an API gateway. If you've got a simple proxy, maybe you can't do auth, maybe you can't do rate limiting, these kind of things. But this is what we're seeing now, kind of in the, almost every cloud vendor has an API gateway, for example, and there are many open source versions too. Cloud native apps. We're all doing microservices these days, right? Because it's the cool thing. I know some folks are pushing back and saying, no, we should embrace the monolith now, but microservices are still where it's at. They're kind of the latest reincarnation of modularization. And if you look back to the 1970s, like David Parnas was talking about, encapsulation and modularization back then. I'm sure many other engineers were doing this kind of stuff even before that. But now we're calling these latest kind of modularization microservices. Hard network boundaries, bounded context, bounded business context in a deployable unit that we can build, we can release, we can operate, and we can scale independently. The thing is, now we're sort of having more independence on these services, but we're still working with heritage tech, with vintage tech, call it what you will. I try to avoid the word legacy because I think that's bad connotation. But if you're working in a big enough shop, you're going to be having a mix of, say, Kubernetes as you're perhaps migrating to this new wonderland. And I do love Kubernetes, it's fantastic. You're also going to have things like VMs in the mix. You're probably going to have, maybe some on-prem stuff. Someone might also be looking to function as a service, some Lambda. There's a whole bunch of things you're going to be routing to now. From an endpoint you give to your user or to the user app, you're going to be routing to lots of different things at the back end. You're going to be using different protocols too. I see a lot of gRPC working with DataWire, a lot of gRPC web increasingly as well. HTTP, see it everywhere with REST, of course. WebSockets quite a bit with sort of real-time stuff. And we sort of see lots of raw TCP, particularly in the IoT space. People are just pumping raw TCP or UDP even sometimes. There's different load balancing requirements. A lot of the more modern apps are happy doing, round robin or some other kind of cool load balancing algorithm. Some of the more vintage apps, you have to do sticky sessions, just the way the session management works. There's also different auth requirements. Between the old world and the new, you've kind of got to make a bridge sometimes. What we're now seeing is what I'm calling the cloud gateway, kind of in the title of the talk, needs to do many things. It needs API gateway type management capabilities. It needs authentication, maybe a developer portal to share your APIs and your open API specs. You need metrics to get that fast feedback and so forth. But you also need, in number 2, ADC-like traffic management capabilities. You need resilience, so timeouts, retries, circuit breaking, all that good stuff. And again, many folks I work with these days are doing quite advanced load balancing algorithms as well, based on geolocation and other cool stuff. Number 3, you need that real-time service discovery. No longer can we say our API gateway is here and we know the IP address of this service is not moving. If any of you, I'm sure many of you have used Kubernetes and so forth, and even in the cloud, you know constantly that your IP address is changing. We can't rely on those kind of layer 4 concepts anymore. We often have to use names for more layer 7 type concepts, the actual names of services to do that real-time service discovery. I do a lot of work with Console, HashiCorp Console. You've got Istio, you've got Linkerd and other things now to do service mesh type functionality. I'm not going to cover much service mesh stuff today, but the gateway needs to integrate or provide similar functionality to a service mesh-like thing, primarily to do service discovery as things are changing. The thing really, though, is microservices lead to an even bigger change, and this is the change in workflow. And Werner Vogels, CTO at Amazon, famously said, you build it, you run it. And I really like that because, when I was doing development, like the sort of as the tail end when I was really into dev, like this made sense. I was doing a bit of Terraform, I was doing a bit of Puppet and a bunch of other stuff too. I took ownership for the whole thing. It was a bit challenging though. It's like a one-person band, right? As in you're doing many things and it can be hard to scale. Well, in a startup, you can get away with it. But in a big organization, everyone doing everything often leads to chaos. But the idea that you own the code from the idea to production is very powerful. And if you look at the kind of big companies and even the smaller successful companies, they empower developers to make those choices. The developers are business aware and they're iterating really fast without the kind of crufty waterfall style of requirements. And because they're moving so fast, often they do need to change the infrastructure. This is the challenge, right? Netflix have got a fantastic blog post where they talk about something called full cycle developers. If you haven't read it, I highly recommend popping along. I'll put the link there for you. I'll share the slides afterwards. But it's all about the platform team providing tools, providing SDKs, providing APIs, providing self-service tools. No longer is it a case we as developers hand off things to ops. We can use their tool suite. This is very powerful, but it changes the way we as developers need to work. If you haven't read Team Topologies, totally recommend it. It talks a lot about models for communication, for structuring teams based on the notion of now a lot of us are having to create a platform or work with a platform or leverage Amazon as a platform, whatever. But then we have stream-aligned kind of sprint teams, we have specialist teams, we have a bunch of other real nice concepts in this book. And for me, it does translate into what I'm seeing with customers that are successful at DataWire. They are empowering developers to work very closely with business folks or bring business folks into the team or be business aware themselves. And they are fully responsible from having the idea, designing, testing, building, releasing, deploying, and then getting that feedback, looking at the metrics coming back. Was that a good experiment? Yes, keep going. No, do something different. But they're often drawing on the platform teams. Yeah, to do this notion of full cycle development where you go really fast, you need to be able to draw on the ops capabilities in a self-service manner. Now, this is a change in workflow. We've often dreamed of this sort of, from waterfall to agile, and then kind of DevOps moved agility into operations and platform. But it's never quite, got there 100% yet. I think with all the tools that are now available to us, we're getting very close to this kind of almost perfect area where we can choose the right technology for the job. And therefore, we as developers are empowered to move very fastly, because our competitors are going to be doing exactly the same thing, right? We are more empowered to be at the front lines, working with customers, listening to feedback, going as fast as we can. I appreciate not every organization is like that. If you're in finance, it's often a bit trickier. If you do like a nuclear power plant, you clearly don't want to be iterating fast, right? But a lot of us who work in e-commerce and other things, we want to go fast. We want to take advantage of this new workflow. The thesis now is the future evolution of the edge is going to be driven by not only application architecture and technology, but also the workflow. This need for self-service, this need for kind of agility at the platform level is a key thing now. It's really, really important. The remainder of the talk, I'm going to look at two of the biggest challenges I've seen as I worked as a consultant and I joined DataWire about 3 years ago with Kubernetes and the edge. I've learned a lot, definitely made a bunch of mistakes, saw some really cool things, part of some successful projects. And there was two challenges that really did stand out as folks are moving to this cloud native way of working, moving to deploying apps on Kubernetes in particular. And the first one was scaling edge management. Now, as a dev team, previously when I had the monolith, my team, we owned the whole thing. If we wanted to change some rate limiting or change auth related to an API, we just tweaked the code, changed the library, no biggie, recompiled, deployed it, or put it on a release train, that kind of thing. Sometimes I did need to change the API gateway, the sort of the V1 of the API gateways. And what I'd do then, the ops team owned that. I'd raise a ticket saying, hey, can you open this port? Can you make sure we support WebSockets? And they'd get back and then we'd have a chat. And hopefully they'd offer some kind of SLA, some kind of service level agreement where they'd say, we'll action any request you make within 24 hours or 48 hours, that kind of thing. And this kind of worked with a monolith. But as we go towards microservices and we lift up these cross-cutting concerns into the gateway, now the challenge is, how do I scale operation of that? We're getting more and more microservices at the edge. So more and more, I want to say, hey, can I tweak the auth for this service? Can I put caching on this service, but not on this service? And if I'm constantly raising tickets with the ops team, they're going to be going nuts, quite rightly. They're going to be pushing back saying, isn't there an easier way? And there needs to be some kind of self-service way where I can define for each of my services what I want in terms of edge responsibilities. Same kind of thing with like the second challenge is supporting diverse edge requirements. And this is kind of building on V1 too, but I've seen a lot of folks now, because we can build microservices, we can choose the right protocol for the job. So, REST is a given, yeah, JSON over HTTP, but I'm seeing a lot of gRPC. Binary protocol, protobuf definition, strong contracts. There's a lot to like about gRPC and gRPC web, to be honest. But I'm seeing it, and again, I'm seeing it a lot in the enterprise. And I'm seeing a bunch of WebSockets too. But we need to make sure that, when we spin up a service and we want to use WebSockets, the gateway supports that. I've been working with a couple companies where, they had a custom gateway they built themselves, and protocol upgrade, HTTP protocol upgrade was not supported properly, and WebSockets didn't work. So we had some problems with Speedy, the old protocol, that kind of thing too. So you really need a gateway that's kind of rock solid, that supports all these different things that are kind of, are options for us as developers these days. And again, we need to mix and match these things. So I want auth with gRPC. Maybe I want some retries with REST, but only on the idempotent stuff. Yeah, I don't want to be retrying transactions at the network level. I want to only be retrying transactions in the business code, for example. And caching, like who hasn't lost countless hours to caching? I know I have, along with DNS issues. But we want to be in control as developers. We want to be able to understand how our service is being configured at the edge very quickly, very easily. This therefore leads to 3 strategies. Now, I've written a bunch about this on DataWire blog and on the website. You can find on IT Next at other places as well. And I've seen folks in general have 3 strategies, or one of 3 strategies, when they're moving to Kubernetes and they realize the edge kind of needs to change. The three strategies are deploying an additional Kubernetes API gateway, extending their existing one, or kind of going all into Kubernetes and deploying what I'm calling an edge stack. Kind of the whole thing just goes, the whole edge stack goes into Kubernetes. Now, again, I've gone into much more detail on the blog post, so you can pop along and read that. And you can always ask me questions on various places you can find me on the interwebs too. But I'll do a whistle-stop tour of highlights of the three strategies here now. So when folks are deploying an additional Kubernetes API gateway, this is pretty simple, right? They literally, the two ways of doing it, on the left of the diagram, you're deploying a new Kubernetes gateway in a Kubernetes cluster, and you're routing the sort of vintage traffic, the existing API gateway, through that gateway into the new world. I often see this when companies are spinning up Kubernetes POC teams. They're doing a proof of concept. They give a team and say, hey, here's your new Kubernetes cluster. Can you wire it up to the existing gateway? And often the ops folks will work closely and say, oh, we'll just route any endpoints of /new through to this new world. And we as engineers, we deal with it as we want to in the cluster. We have to have some form of API gateway, some form of ingress. So we spin up a second gateway in there. Often the dev teams I've seen manage that gateway, and the platform teams manage the existing gateway in the sort of the heritage vintage world. I see some folks on the right also doing it at sort of more the layer 4 level. They may have a global load balancer or some kind of load balancer there. Then they're splitting more based on domain names or subdomains or ports, these kind of things. And they kind of, then the load balancer splits traffic accordingly to the old or the new world. That's a valid tactic too. The pros are obvious with this. There's minimal changes to the core edge infrastructure. Your core edge stack of all the stuff that's running outside of Kubernetes stays the same. Incremental migration's easy. There's low risk of things blowing up because you're tagging a new thing on the end basically, or to the side. The cons, you're now working with two API gateways. I had a real gnarly debug issue with a customer where we just couldn't get the API gateway working in Kubernetes properly. And then we realized what the deal was is the old API gateway was stripping certain headers. And there were some security headers that we needed, which kind of made sense to strip out in the API gateway, the original one, when it was the single point of ingress. But now we had these two layers, like just finding that problem alone was a nightmare. We had to work closely with ops and we were, oh, we're missing header, security checks failing. Where's the header getting stripped? It's in the API gateway that was there since the dawn of time. So be careful. Working with two gateways is tricky. And it is, and the way you sort of interact with both of them can be quite tricky as well. It is often challenging to expose all the functionality you need in the Kubernetes cluster in a sort of Kubernetes friendly way. You're often writing YAML to configure the API gateway. Well, obviously you can configure the Kubernetes API gateway, but not the vintage API gateway. Therefore, you have to raise tickets, which can slow you down. If you've got a good SLA, got a good relationship with your ops team, it can sometimes be fine. But this can be a bit of a slowdown when you really get up to speed with Kubernetes and lots of microservices. The second strategy is extending the existing API gateway. I see this a lot where folks have kind of invested in their own gateway. I see in the Java space, a lot of folks sort of modifying Netflix's Zool. I've seen some folks using Netty and a bunch of other cool things. It is interesting, like once you've invested in the edge, often you're reluctant to let it go. Sometimes it's a bit of a sunk cost fallacy in that you've put a lot of time and money and love into this API gateway. You don't want to let it go. So as you're moving to Kubernetes, you just try and extend the existing gateway. Sometimes it works, sometimes it doesn't. Yeah. And really, it's primarily focused on syncing up your endpoints that are exposed in the API gateway with the services you're deploying into Kubernetes. So I've seen some teams and also commercial products like F5 offer controllers that sit in your Kubernetes cluster. You can write annotations on your Kubernetes YAML, in your Kubernetes deployment descriptor that say, map this endpoint, / whatever, to this service. We then deploy our application into the Kubernetes cluster. The controller, say like, the F5 controller that's sitting in that Kubernetes cluster is looking out for annotations. It goes, oh, new annotation, new endpoint's been defined. It then makes out of bounds or out of band call to the existing API gateway and configures that gateway. So it's quite a nice way. You're using kind of Kubernetes friendly config and you're writing, using Kubernetes friendly ways, but this controller or an operator, sometimes they're called, that's sitting in the cluster and automatically listening for these annotations makes the changes to the API gateway. The pros for this, same as previous, right? You can reuse your existing tried and trusted API gateway, providing you don't hack it around too much. I've seen some folks really sort of pulling the guts out of their API gateway, and that can lead to, quite high risk, I'll be honest. But if you're sort of bolting on things on the side, maybe you're, like I mentioned, F5, maybe you're using the F5 controller, really it's minimal risk there because the controller is literally calling the API that's always been there on your F5 load balancer, for example. The cons. Workflow has to change to maintain a single source of truth. Again, worked with a couple of customers on this where we had collisions where in the Kubernetes world, we were defining new routes, /shop, but they were conflicting with old routes, or we were sort of had like a race condition where both of us were doing new routes and just messing up with each other. And because we were both using different deployment frameworks, it just got messy. And you can argue that's more of a deployment thing than an API gateway thing, but I think, again, the workflow kind of goes hand in hand with how you use these API gateways. There is limited amount of configuration parameters via the Kubernetes annotations often. Definitely if you're self-built, you'll find you want to do more stuff in your Kubernetes YAML than the gateway is capable of, or even if you're using commercial tools, same deal. You want to do something you've always been able to do with the API gateway, but it's not supported in the current version of the controller or operator that you've got from the vendor. So just something to look out for. Do think ahead of your sort of where your roadmap's going, what functionality you want, and match it up with all the vendors' roadmaps and make sure there's clear alignment there. The third strategy, deploy an in-cluster edge stack. And this is kind of where you just go all in. If you're greenfield, this is pretty much what folks are doing these days. But let's be honest, there's not many of us that are greenfield. Most of us have to work typically with strategy 1 and 2. Maybe we even aim towards strategy 3. But if you're greenfield, probably you want to go all in with the Kubernetes. Kubernetes sort of friendly config around load balancer, API gateway, and things like web application firewall too. The beauty of this is like the ops team often manage the platform, they manage the API gateway and the WAF and so forth, but it's very easy for us as developers to code that YAML that says, this is how I want the gateway to work with my service. Yeah, because it's all in Kubernetes, you get all the benefits of being able to write and all the functionality that you want into those YAML, into those config files. Often I say the ops team own these things, provide same defaults, like maybe they enforce TLS everywhere, maybe they enforce you must have authentication on every endpoint, these kind of things. But dev teams, we're responsible for configuring the edge stack as part of our normal workflow. I just got my pointer there. So the pros, edge management is simplified into a single stack. There's no more worrying about the existing API gateway and these things, but this is kind of an idealized world. If you're greenfield, big tick here. If you're brownfield, clearly you're going to have other things there. But if you are starting as greenfield thing, going sort of all in on Kubernetes rather than having a load balancer or API gateway sitting outside, I would recommend going all in on the Kubernetes approach. It does support things like the single source of truth, which is really powerful because then if something goes wrong, it's instantly in the code you've got available to you, and it's not a collision between old and new. GitOps is kind of a buzzword, but a very powerful buzzword, I think. If you're not familiar with it, well worth a Google around GitOps, understanding that the way we as developers say build and push our applications down a pipeline and deploy, we can do the same thing with platform config. We can code up in our Kubernetes YAML, I want this amount of CPU for this application, this amount of memory, and this is how I want the auth to work. This is how I want rate limiting to work. This is how I want caching to work. It's very powerful if we can understand all the things, or at least look at all the things, and maybe we sort of consult with ops. We say, hey, I'm not sure what this caching means, but again, we've got like that single source of truth, very easy to look and understand what's going on if we're defining all our deployment descriptions and using the same pipeline to build, test, and release that code and that config. The cons are equally as obvious. It's a big architectural shift, if you're going from old world to new world. I've seen some folks struggle around learning new proxy technologies. So Envoy proxy, Ambassador is built on Envoy, as is Contour and others. It's a very popular new piece of edge technology. It's fantastic. I mean, you come out of Lyft, which is like a Uber in the States, an Uber competitor. Google are heavily involved, lots of engineers committed to it. Microsoft using it on Azure, AWS are using it. Like Envoy seems where the momentum is at in terms of proxy technologies these days. I'm sure Nginx and HA Proxy would argue otherwise, and like it's definitely a good discussion to have. But if you are moving to a cloud native way of working, you might have to learn something like Envoy, or your platform team might have to learn something like Envoy. And Envoy is very different conceptually than some of the classic edge proxy technologies. So as much as we as developers have to learn new things around the API gateway, the ops team are going to have to learn how to deploy the new thing and operate the new thing. This can be scary, and it clearly impacts on our, on our time and budget. Wrapping up, now I appreciate that has been a whistle-stop tour. You can find more information, like I say, on the blog post, which I'll share later on. The key things I wanted to really leave you with is that there has been a clear sort of evolution driven by technology and architecture over the past 20 so years at the edge. We've gone from hardware to software. We're looking like networking layer 4, so IP addresses, ports, to layer 7, HTTP metadata, browser config, device config, these kind of things. And we're also moving from centralized management, where it was the ops team did everything opsy, dev team did everything dev focused, to this more decentralized way of working. Ops team provide a platform. We as development teams are, enabled to deliver value to customers in any way we see fit. This means that, this move to sort of cloud native, which is personifying microservices, functions, cloud, Kubernetes, is changing the workflow. When we've got this centralized, resource, but decentralized teams, we need to be able to scale working with the platform, scale working with the edge. We need to also support multiple protocols, because again, as a developer, my service, I want to choose the best protocol for the job. I want to configure caching appropriately. I want to make sure auth is configured appropriately. Now I've got to do all that sort of in my deployment descriptor, right? Because we're going so fast, we don't want to be raising tickets and doing all these other things. The bottom line is choose your platform, and in this case, your cloud API gateway intentionally. I've seen the most challenging projects I've worked on over the last 5 years are when folks have just sort of lifted and shifted their old mental model and often their old technologies into the cloud. It often works, it kind of gets you so far, and maybe that's the route you have to go to start, but be careful doing that. I think the best migrations I've seen, the best adoption of cloud I've seen, folks have stepped back a little bit and thought about what their requirements are, matching up to the skills of the team, matching up to their relationships with vendors and where they see themselves going in the future. I just think the platform these days is so important, and the edge, in my perspective, is so important that don't just lift and shift. Really think about the strategy you're going to be doing and look to make it as frictionless as possible for developers, because now we do often need to tweak things at the edge, make it part of the regular workflow. I've talked a lot recently, New Stack article on the left there about the need for a playground for Kubernetes, because often there's a lot to learn on Kubernetes, I'm not going to lie. You need some way of spinning up fast things, playing around with this stuff. So I've talked more about that in this New Stack article published a couple of weeks ago. I'm working on a project, a free project, no registration required. Pop along to app.getambassador.io, the Kubernetes initializer. We've done it for you. It's like a wizard. You answer a few questions: where you're running your Kubernetes cluster, what kind of ingress do you want? Do you want continuous delivery, Argo, baked in, and a bunch of other questions, and we pop out YAML at the end, custom generated for you. You can literally take that YAML, apply it to your cluster, and you've got a full playground to start playing around with. And I find this is invaluable for folks I work with. I just say, hey, answer the wizard, spin up your cluster, deploy all this stuff, deploy some apps in there and start playing around. It's the best way to get a feel for a lot of these things. So you can check out those there. And lastly, thanks a lot. Check out the blog. I do some podcasts with DataWire and InfoQ. So love your feedback on those as well. You can find me on the DataWire Slack, and you can also tweet at me and get involved in the DevOpsCon chat as well. Thank you very much. I presume we might have some time for questions now. Let me just double check. If I stop sharing my screen, I can pop along to the
Is everything all right?
Yeah, all finished. Thank you.
Oh, you're finished.
Yeah.
Oh, sorry. Yeah, that's all, folks. Thank you, Daniel. There's a question. You mentioned that an API gateway now needs to provide much of what a service mesh could otherwise provide. Do you see that as for the simple case where more advanced users would have a service mesh and simpler API gateway, or when you use, or would you use an API gateway over a service mesh?
Yeah, Mark, great question. So I see like definitely a lot of interesting discussions in this space. So what I say is the API gateway is very much north-south focused, so ingress focused. Taking the users into your backend services. The service mesh is very much east-west focus, as we traditionally used to say, focused on service-to-service comms. We are seeing some service mesh, like Istio has a notion of a gateway. So does Console, has terminating gateways and ingress gateways. So service meshes are pushing in to the API gateway space for sure. I think at the moment, they are two separate areas. So the north-south use case is often more focused on the end user. So if you look at a lot of the API gateways out there at the moment, there's lots of richer authentication options, richer developer portals, these kind of things, compared with the service mesh space that's still a bit young, a bit immature perhaps at the moment. So I definitely see there's a lot of similarity around sort of the OPSI requirements, things like timeouts and so forth. And as perhaps more and more of these edge requirements bleed into our systems, maybe you want to do authentication and authorization on a sort of per service basis, then maybe we do see stuff at the edge moving more into the service mesh. But at the moment, I think they're two distinct use cases.
Okay, thanks again, Daniel. There are no other questions as far as I can see, but you can rate this talk in Swapcard, and you should. And there's a 5-star rating system. And with that, thank you for the to the audience, and thanks, Daniel. And
thanks a lot.
Have a nice time at our conference, folks.
Appreciate it. Thanks, everyone.